Hey, hello physicists, what's the crack? So what we're going to do now is some paper free section A about graphs, okay? So this graph, what they said, is this data from a student. They said that it shows that y can decrease exponentially with t, and the question said, show that y, the decay constant for this process, is this number, okay? So the key thing is for paper free, they're assessing you on everything in physics, right? So as soon as you saw decay constant, you should be thinking that the decay constant's got something to do with my nuclear physics. So what you do is go to the nuclear physics section in your data sheet, and you should see the equation n equals n0 e to the minus lambda t. Okay? So what that means is n, the number of nuclei we have left, is equal to n naught, the number of nuclei we had at the start, and then it exponentially decreases with time due to that decay constant. Okay? But I don't know time zero, right? Remember, they like to do this in your physics paper. They never start at zero, so always just check what numbers they start at. So because they don't start at zero, I can't use the exact equation, but I can change it slightly to figure out that n2, value 2, will equal n1, e to the minus lambda, change in time. Okay, so I can use two values on my graph and use a change in time. Okay, so the two values, when this was the paper that I looked at, I went across at 59.8, I went across and down, and I saw that matched up with 30. And then when I did it earlier, and I went across at 50, I went across and down, and I saw that number matched up with 70. Okay, so n2 is the lower number, remember, because it drops. So the lower number is my 50 equals my n1. I used 59.8. But again, you can use any set of values you want, just as long as they match up and you record those two numbers. Okay, so I used 50 and 59.8. E to the minus lambda, the change in time. So my two times are 30 and 70. So my change in time is 40. Okay, so what I can do first is divide both sides by 59.8. So I have 50 divided by 59.8 equals e to the minus lambda times 40. And then hopefully you can see, to get rid of that exponential, we take natural logs of both sides. So what I'm going to do is take a natural log of both sides. So natural log of 50 over 59.8 equals the natural log of e to the minus lambda times 40. I know from my math lessons, if I take the natural log of e to the base e, that just cancels out. So what you get left with then is your minus lambda times by 40. Okay. So if I want to find what lambda is by itself, just going to pop it over here, to find out what the decay constant is by itself, all I need to do now is divide this number by 40. So I'm going to do 1 over 40 multiplied by my natural log of 50 over 59.8. Okay. Okay, so we divide both sides by 40. So when I did that math earlier, I got my decay constant to come out at 4.47 times 10 to the negative 3. And it wants me to prove that it's 4.5. So I'm just going to write beneath that that is equal to 4.5 times 10 to the minus 3 if I write it to one decimal place. Okay, so that's grand.